All right. And it's just you and I right now.
Maybe nobody will show up tonight.
Yeah, maybe we get the night off. I doubt it though. I think 5 people that were already registered. So I think those people will show up. You would think Ian would show up. What the heck? Okay. He always strolls in a bit late.
I wouldn't mind a night off. Like I said, I have a massive headache tonight. I don't know why. I've been
Last
staring at
Monday.
the screen all day, so probably that.
Yeah, that'll mess with you. I tried at work. I Our plaza has actually a nice green belt. It's a business park, but it has a nice green belt, lots of trees in it. So I try to give myself a little bit of a break because my eyes start getting all cross-eyed. Hello, Carlos. Give everybody a little bit of a time to go ahead and join us. A little light tonight. Our audience already knows all about regenerative peptides.
Yeah, tonight was kind of interesting. I put together a presentation that kind of, lately in working with a lot of people with peptide protocols and therapies, I get a lot of people just saying, "Hey, is this gonna fix all my problems? Is this going to make me feel better?" And it's just kind of like I'm trying to really hit it home to people that, no single peptide is a magic bullet. I mean, these things are very targeted. They work on very specific mechanisms. They're not drugs. And tonight's episode is really to kind of show how different peptides work with each other to support each other,
Mhm.
and that there's kind of like no single. I mean, we're going to talk briefly about the mechanisms of a bunch of peptides that we've already spoken about, but more in a circular manner, kind of showing how they support each other and how it all starts at mitochondrial dysfunction.
It's more and more we're finding that the mitochondrial dysfunction is at the root of many of our chronic diseases. I
Yeah.
mean, it's just there. I mean, uh, before we hopped on, I was reading a wonderful page turner, low level light therapy and brain health, and that's all about stimulating mitochondria in the brain. Um, so anything that is going to improve that mitochondrial function body wide, you're talking huge benefits to the human body. So,
Absolutely.
all righty. Well, it is now. Heather, glad you joined us back. Um, it is now 5:03, and we're going to go ahead and get started. Uh, Today, we were just talking, probably is going to be somewhat of a review of some, but we're going to go deeper into some of the mechanisms underneath how some of these peptides interact with each other. I'm looking forward to this presentation myself. We were discussing about neuropathy and some other things before we got on, so looking forward to tonight. Um, so we do have a little bit of housekeeping that we do have to do. I will let everybody into the chat here in just a moment. Chris is going to go ahead and take care of the legal, so we keep ourselves on the right side of the law. And I'll be doing the tech stuff to let everyone chat and converse with each other.
So, before we begin, let's understand that everything discussed in today's webinar is strictly for research and educational purposes only. Any compounds, peptides, protocols, or dosing information mentioned or discussed are intended for research context only and are not medical advice. These substances are not intended to diagnose, treat, cure, or prevent any disease. Nothing shared in this discussion should be interpreted as a recommendation for personal use. Always consult a qualified healthcare professional before making any health-related decisions for you or your giraffe.
Yes. Kangaroo, if you happen to
Kangaroo,
have one of those.
giraffe, wombat, whatever you got.
Wow.
Whatever you're experimenting on.
I like the wombat.
Whatever your spirit animal is.
There you go. There you go. All right. Can somebody do me a quick favor and just throw something in the chat to make sure that it's live and working? The Q&A is also live, so everyone should be able to jump in there. Beautiful. Thank you. Hello, hello. Glad to see everybody here today. Thank you for joining us on this beautiful Tuesday evening. All right.
Cool. Well, I've prepared a little PowerPoint to go along with the discussion today. So let me share my screen. Share desktop. And
Yes.
how do I make this go full screen? View
You're going to go to, hold on,
screen.
full screen. And
All
then there
right.
we go.
Are
You
we
got it.
beautiful? All right, we're beautiful. All right. Tonight's discussion is the science of regeneration with peptides. So, what does that really mean? Like, we're talking about biological systems and protocols. So, we're not talking about one particular thing with peptides tonight. We're going to have a discussion about how multiple different levels of multiple different peptides work together to not mask symptoms, but to really change biological systems and states from the ground up. Things that are going to be discussed are mitochondrial optimization, metabolic reprogramming, cellular repair mechanisms, immune modulation, and longevity signaling. So what do we really mean by regeneration? What does that mean? So there's 5 main components that basically make up regeneration. Like I said, we're moving beyond symptom management to biological restoration and repair at a cellular level. And so that's a multi-pronged process. So you can think about this across these 5 mechanisms: cellular repair versus replacement. So we're talking about fixing damaged cellular machinery rather than just replacing dead cells. Mitochondrial optimization, restoring efficient ATP production and reducing oxidative stress. So this is really important. The mitochondrial optimization, as we go through further, we'll kind of see as sort of the cornerstone to all of this. Stem cell signaling, activating endogenous progenitor cells for tissue renewal. Inflammation resolution, switching from chronic inflammation to healing pathways. And the last one being hormetic signaling, adaptive stress responses that strengthen cellular resilience.
Beautiful.
So the core biology of regeneration. Physiological regeneration is really about, it's like a concert effect of things. It's like it says here, a coordinated biological symphony. It's not about growth. It's not about energy status. It's signaling efficiency and structural integrity. So we're going to talk about NAD's role in all of this, basically supporting the very bottom level of mitochondrial efficiency and mitochondrial biogenesis, which actually brings us into AMPK signaling, which the mitochondria does. So we're going to talk about particular peptides like MOTC and SS31 and how those work together, and actually the difference between those two as well, both being mitochondrial derived peptides. AMPK signaling is very important. This is the switch that triggers all autophagy and cellular cleanup. So autophagy, we've discussed in the past, is the sloughing off and getting rid of old senesced and dead cells that aren't sort of pulling their weight, right? And then we've talked about mitophagy as well, which is going deeper inside of the cells at a mitochondrial level and getting rid of old senesced mitochondria that aren't pulling their weight, that are actually sort of working on an energy deficit rather than having, pumping out extra energy. They're actually taking more energy to pump out less ATP than they're actually the energy that they're using to do so. And then the last piece is going to be redox balance, managing that reactive oxygen species and that oxidative stress to prevent damage during healing. And then the last thing we'll discuss is extracellular matrix and repair. So the rebuilding and the structural scaffolding, the collagen, elastin, the actin remodeling required for tissue integrity. So we're going to talk about a lot of different groups of peptides. In the extracellular matrix and repair, we're going to get into GHKCU, some BPC and TB, and a couple of those. So we're not going to dive deep into each peptide, but we are going to hopefully kind of stitch together a picture tonight of how they all work together to support each other and how there's not really one silver bullet or magic bean in the bunch, but how they all kind of support to each other. And these 5 pillars of biological process will show us that. So NAD is the first thing we're going to discuss. So NAD is a regenerative currency, right? So every single cell in our body has NAD. If you don't have NAD in that cell, it's a dead cell. What is NAD? We've discussed this in the past, but it's sort of peptide adjacent. It is not actually a peptide. It's a larger molecule than a peptide, and NAD plus actually stands for nicotinamide adenine dinucleotide. And it's a critical coenzyme found in every living cell, and it acts as the fuel for the regenerative process. So it's essential to have proper NAD production or NAD infusion into the cells for mitochondrial function and to create that ATP. So it's essential for the ATP production, and it's required for sirtuin activation and DNA repair, the PARPs. Like we talked about those heavily, I think it was 2 weeks back. We really talked a lot about the sirtuin activation and the DNA repair. And all of these things decline with age, and they're all linked to metabolic resilience. So, a little nice graphic that I pulled off the internet that you can find here. So yeah, without sufficient NAD, cellular repair mechanisms, they don't function. And so if certain things are off, we talked about this a little bit last week. If somebody is actually taking something like retatrutide and they're not finding like great inroads with it, like they're not finding the results that they feel they should have or think they should have with it or would normally have with it, oftentimes it points to a greater metabolic dysfunction, often at the level of mitochondria. So oftentimes when we're doing that therapy with somebody, working with the GLP, and they're not getting the results, we sometimes pause on that and we do a round of MOTS-C and a round of SS31 to usually paired with NAD plus and oftentimes methylene blue to really get that mitochondrial function online and get that efficiency moving so that the other things down the line, like the GLPs, can actually do their job properly and you can get what you should be getting out of them. So MOTS-C is the next one. It's a mitochondrial signaling peptide. It is derived from mitochondria and it's actually encoded with the mitochondrial genome itself. It's a 16 amino acid peptide, which means that there's actually 16 different aminos in the chain. And this triggers AMPK master switch activation. We've talked about the AMPK activation before. MOTS-C really brings that online to a major degree, and retatrutide, the other GLPs don't, but retatrutide most definitely brings the PK activation online as well. And it's really just a master switch uh, for metabolism and energy homeostasis. So this is actually working with your glucose uptake and metabolic flexibility. So it's helping your body and your cells switch between fatty acid and glucose oxidation. So when we don't have that fatty acid oxidation, many times that's what creates that. We keep hammering the head on the ROS, the reactive oxygen species, every week. We're talking about that in some way or another. And this is MOTS-c really helps tune that up. And you'll see even more so the SS31 when we get to that one. So MOTS-c is actually known as an exercise mimetic, which means it brings some of the same functions to the cell that physical activity and training does, right? It also brings some of the same things to the cell that fasting does. So fasting does the same thing. If you don't have money for MOTS-c, you can literally bring almost the same thing into your body by doing, like a couple of day, like a 2 or 3 day water fast will bring the same kind of exercise mimetic and the same kind of benefit of mitophagy to the cells and getting rid of all those old senesced cells or senesced mitochondria and building up an army of new mitochondria.
What about intermittent fasting?
Intermittent fasting does a little bit of that as well, but I think to really get that mitophagy happening, you really have to go, I think you have to go over I think it's around 37 or 38 hours or something like that. If somebody knows the exact thing, they can put it in the chat. But I believe the last time I was reading about that, it's somewhere around 37 to 38 hours that that activation actually kicks in and mitophagy actually begins to happen within the cells. So SS31, also known as elampretide. So this targets cardiolipin, binds selectively to cardiolipin on the inner mitochondrial membrane. So we've talked about this a lot before. The MOTS-c creates mitophagy, gets rid of all the old senesced mitochondria, and builds that new army of mitochondria up in its place. And in doing so, there's a little bit of reactive oxygen species left over, especially when we're doing that at such a fast rate. It takes a lot of energy and a lot of metabolism to actually build that new fresh army of mitochondria. And the SS31 cycling after the MOTS-c helps to stabilize all of those new membrane walls of those new mitochondria. It helps reduce the reactive oxygen species that's built up sometimes by all of that new fresh mitochondria building. It prevents the electron leakage and subsequent oxidative damage to the source by getting that reactive oxygen species out of the cells. And again, it stabilizes that membrane and tunes up the electron transport chain function. So in doing so, it's improving ATP efficiency and without increasing oxygen consumption. And this has been studied extensively in cardiac failure, muscle aging, and mitochondrial myopathy. So and I believe SS31 is one of the peptides that's actually it's either already FDA approved or will be FDA approved pretty soon, I believe. Not that that matters in this group because we like to do lots of experiments on kangaroos and giraffes and whatnot. Anyway, the next one we're going to talk about is retatrutide and metabolic reprogramming. So this is the triple agonist, and having the glucagon receptor agonist is very important to this. On top of the other two agonists from the other two, the semaglutide and the tirzepatide, and we've beat this over the head, I think, to death over the last 5 or 6 weeks, talking about the difference between retatrutide and those other two and how this differs so much. So this is simultaneously targeting three different receptors, the GLP-1, the GIP, and the glucagon receptor for a very synergistic effect. It's working more than just the appetite and more than just the metabolism, but with those other two GLPs, you get basically less energy expenditure, right? And what's happening with when you're adding the glucagon is you're getting more energy expenditure. So this is actually becoming more about optimization and energy expenditure and metabolism and metabolic activity. So the weight loss is going to be more about metabolic activity than just like appetite suppressant, like with the GLP-1 or the GLP-2 primarily. Um, Adding that third receptor agonist also dramatically improves insulin sensitivity and improves the glucose transport mechanism and the homeostasis in insulin response. So that increases energy expenditure. It increases resting metabolic rate through glucagon receptor activation and brings metabolic remodeling on a systemic level. So um, that really has a huge effect when we're talking about fatty acid oxidation, right? So the metabolic flexibility and adipose tissue remodeling that happens when you have that fatty acid oxidation. So the regeneration really requires energy. So I said in the beginning of the presentation how we were gonna, what's
Real
that?
quick, we do have before we get too far, it was on retatrutide, the triple agonist, and would recommend its stacks that go along with the retatrutide, and really wanted to know if could it be used in combination with MOTS-c.
Absolutely. So it is oftentimes, actually most oftentimes, used in conjunction with MOTS-c. And then oftentimes, well, anytime MOTS-c is used, it's a good idea to stack it with NAD plus as well, or something that's going to bring a similar electron transport chain and tune up into the cells with extra oxygenation into the cells, something like either NAD plus or methylene blue or both. Um, so the third thing in the stack that usually happens with retatrutide, so it's retatrutide, MOTS-c, and 5-amino 1-MQ. And we were discussing this earlier, right, Tony? We were
Mhm.
discussing the
Absolutely.
5-amino 1-MQ.
Hmm.
So with the GLPs, especially the GLP-1 and the GLP-2, some of the biggest problems with those particular receptor agonist peptides is that there is as much muscle loss or more than fat loss, right? And also other things like bone density loss, especially in women. So there's all these other side effects that aren't really seen as much with the retatrutide, but also if you stack it with a 5-amino 1-MQ, it has a lot of muscle preserving qualities to it. So also the 5-amino 1-MQ. So those three things together basically turn your body into a fat oxidizing furnace. And you're just gonna like destroy all of your visceral fat at the same time as keeping lean muscle mass on. The 5-amino 1-MQ is really, really well targeted for that. Um, Many bodybuilders that want to do retatrutide for like a cut or to, while they want to continue building lean muscle mass while they're doing a cut and trying to getting rid of visceral fat, they'll oftentimes stack those three together. The retatrutide, MOTS-c, and 5-amino 1-MQ. That's probably the most common stacking with retatrutide.
Real quick, now, if you were doing that stack, I know that we've mentioned in the past that MOTS-c, you want to cycle off the MOTS-c and then add in your SS31. Um,
Absolutely. Yeah.
would it,
So we've talked about that at length and
um,
basically what it equates to is when you're taking the MOTS-c, you're building a new house. And when you build a new house, there's always a little pile of trash left over to the side of your house after building that house. All the leftover cut ends of the 2x4s, leftover roofing, some wiring, some stuff left to the side. It's kind of the same. You could use that analogy with the MOTS-C. In building all that fresh new mitochondria, there's some few trash proteins and a few ends of things left over. And we call that reactive oxygen species, right? The ROS that we talk about getting out of the cell. And the SS31 cycled behind that tends to really again, tune up that electron transport chain. It strengthens and fixes all the walls of that new fresh mitochondria that you've just built up and really helps take out the trash and get that all out of the cells. So that would definitely be stacked at the same time as well. So, but generally speaking, a cycle of MOTS-C is going to be like 2 to 4 weeks long. We generally cycle people for about 3 weeks. And then after that 3 weeks, you would cycle on to SS31 for 3 weeks to a month and sort of have that clean out. And by doing so, you've then built up this huge new army of mitochondria. You've then cleaned out the cell and brought like more mitochondrial efficiency to all of that new mitochondria that you've just built. Does that
Beautiful.
answer the question?
Yeah, no, I was just because I know that MOTS will build up some of that garbage in the cell, let's say. So staying in on your retatrutide, your five amino, cycling on and off the MOTS, and then
Yeah.
adding in the SS31 while you're off the MOTS, then back.
Yep. Yep. That's the most efficient way to do that.
Beautiful. And
So the regeneration, this requires energy, right? So when we talk about regeneration and all of these peptides, they require some animal some energy, like anabolic features in the body require ATP. They require energy, and ATP is that. We keep using the analogy of ATP being the cash and the currency that's out in the world running everything, and mitochondria in the cells is sort of like the Federal Reserve that's printing all that cash and making all that money that everything runs on, right? So you'll notice this is kind of circular in one direction down to tissue regeneration, but it kind of goes in two directions. So mitochondria, it starts at mitochondrial health, right? Like the foundation of cellular energy production is mitochondrial health. So with mitochondrial health, signaling pathways of AMPK and NAD plus activation happens. So you need the NAD plus to be efficient in the cells for the mitochondrial health to function because it needs that for the ATP, but also the mitochondrial health helps build more NAD plus in the cells naturally, and then causes the AMPK activation as well. So all of this um, sort of requires like insulin resistance being lower, right? So as we age and all of the modern factors of life as a human these days on this planet have caused insulin resistance in pretty much the entire population. As we age, everybody becomes more and more insulin resistant. So all metabolic diseases they're now kind of finding boils down to insulin resistance in a way. You know, we've talked about it at length in the past couple of weeks how type 3 diabetes is now what they're calling um,
Alzheimer's.
Alzheimer's and dementia, right? So it's not being caused by what they thought it was of, an amyloid plaque buildup in the brain. That's not what's causing Alzheimer's and dementia. That's sort of a byproduct of insulin resistance. And so it's the insulin resistance, which is actually the root of those issues, those diseases, right? Those metabolic dysfunctions, really. So the metabolic dysfunction and the insulin resistance is really creating an energy block, um, basically stopping tissue regeneration. So when we talk about things like, let's actually talk about tissue regeneration, TB500,
Mhm.
GHKCU, BPC-157, things like that that are actually working on angiogenesis, rebuilding rebuilding actin models in the body, rebuilding like the GHKCU is actually working at a transcriptional level, and we'll see that in a couple slides coming up here. We'll probably illustrate that better than we have in the past. So all of this requires ATP production sort of in a circular manner, right? So the tissue regeneration requires energy. It requires the currency for protein synthesis, which is ATP production. Well, there's no ATP production without mitochondrial health, and none of those signaling pathways work without the mitochondrial health. So it's kind of a circular function that we have going on here. So the mitochondria precedes the repair, the insulin resistance blocks the repair, and the AMPK activation, the NAD plus into the cells, and that synergy is what basically creates the mitochondrial health, producing more ATP, which allows for tissue regeneration and all the signaling pathways to work correctly. So this is kind of like the point of this entire presentation is right here. This sort of circular graph that you can see, and it all boils down to insulin resistance and mitochondrial health.
I want to just tie up something real quick for Heather. Um, on the SS31 and the MOTS-C, what's the time frame? I've always thought that the recommendation, or at least in study wise, that MOTS-C, if you were on for 8 weeks, you'd want to be off for 4.
So MOTS-C, generally we say you could be on it for 8 weeks if you really wanted to be.
Hmm.
But in all of our studies and in all of our work writing protocols with people, we've found that doing a higher dose for a shorter period of time, getting like a new army of mitochondria in, and rather than like stacking that army of mitochondria for a long, 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 long time, doing a
Hmm.
shorter burst of it, and then coming in with the SS31 immediately right behind it to clean up what you've built already. Then go
Hmm.
back and then build some more and then come in and clean it up with the SS31, right? So it's the idea behind that is not waiting until the army is too large before coming in to clean up that reactive oxygen species and not letting too much of that, so to speak, rust build up in the cells for
Okay.
too long before we come in with the trash collector, right? It would be like you can think about it as like if your trash man didn't come once a week, if they came, every 2 weeks or once a month,
Okay.
you'd have maybe, more bags outside your garbage can sitting to the side of your garbage can that won't fit in your garbage cans anymore.
Okay.
So we kind of that's sort of the analogy behind that.
And what about timing on that?
Uh, I mean, we generally say no more than 4 weeks on the MOTS.
Okay.
And, we used to do sometimes, a milligram a day, 5 days on, 2 days off, or even every day. We've found that signal flattening and receptor wear is a real thing. And it can certainly be when talking about mitochondrial peptides. So we found that giving your body little breaks so that we don't have that signal wear and in turn receptor flattening and having more bigger pulsatile events with
Okay.
time in between. We've discussed in the past many peptides work pulsatilely, right?
Mhm.
Um, it's not just the growth hormone ones that happen in natural pulses in the body and those working pulsatilely, but all peptides are mostly working on pulsatile signaling, right? So having breaks in between and not just slamming your receptors with those every single day tends to be working better. So if I were cycling MOTS-C with my kangaroo or my giraffe, I would be doing it 3 times a week with 4 to 5 milligrams or maybe even more. You could do up to 10 milligrams um, three
Go
times a
ahead.
week if you really wanted to. I don't suggest that. People tend to be quite sensitive to that, and you can start to get some like you can get some hives and rashes and some things, especially at the injection site happening. using that much, but 4 to 5 milligrams 3 times a week is very solid plan with the MOTS for like 3 weeks. Go intense 3 days a week for 3 weeks, and then either take a break, really up the NAD, or go straight into the SS31 with NAD plus.
And how long would you be on the SS31, or how long would you
3 to 4 weeks as well. Yeah.
okay. So it's an
Mhm.
equal cycling.
Yeah. Hmm. That's what we've found very effective. All right, GHKCU. Everybody loves this one, right? So this is actually working. We've discussed in past episodes how this is actually working transcriptionally. This is actually working at a gene level, right? So this GHKCU is actually modulating over 4,000 genes, and it's shifting cells to a healthier, younger state. And what it's actually doing is, it's building collagen, but what it's doing is it's building very strong collagen and it's strengthening the collagen that we already have, right? So, this promotes angiogenesis signaling, which is the formation of new blood vessels and nourishing all of that tissue, which is one of the reasons that it goes so well with TB500 and the BPC 157. And again, I'm going to say it again and again every episode. The GHKCU copper, because it is working at a transcriptional level on genetic expression, and it's working much longer, and it also um, has a totally different pH and a totally different polarity in a vial and in your body than those other two, that it needs to be moved 30 minutes apart from those other two. And I would suggest it to be 30 minutes after the other two, as the other two, BPC and TB, are going to build a better scaffold for this to work on, right? You're going to have better proliferation, better angiogenesis, and collagen building if you're using this after the BPC and TB. So again, wound healing. This accelerates tissue repair through enhanced fibroblast activity. So again, that coming in behind the actin remodeling that TB500, the angiogenesis that TB500 is creating as well. Super copacetic with this, but the TB500 is going to be building a better scaffold for this to work on. And then this is going to work for much longer than the BPC TB, as those have, let's say, a 20 to 22 minute signaling half-life. Whereas the GHKCU is going to have like much more of a half-life, like 2 to 3 hours or more. So the collagen stimulation, it increases collagen production and structural protein synthesis. And like I mentioned a minute ago, with the protein synthesis that it creates, the collagen fibers that it's going to help model and remodel are strengthening and tightening the collagen fibers that are there, that are happening with this peptide. So it is a natural peptide complex. I kind of went backwards on this list, just because I felt like the gene expression is really important when we're talking about GHKCU. So it's really facilitating proper uptake of copper into the cells at a cellular level, right? So that has to be done very efficiently in the right manner to not create the wrong buildup of copper in the cells. And GHKCU really helps the body do that in an efficient manner. Um, any questions about that?
Hold on, I got one new message on here. Does a combination also help with joint repair or sports injuries?
Absolutely.
Hmm.
So when we talk about the collagen stimulation, so a lot of people tend to think that collagen is just about, plump skin and like having, like nice skin and facial structure and things like that. But when you really get down to it, when you're working out and you're training at the gym, or you're repairing from an injury, muscle fibers start with collagen fibers. So some of the very beginning synthesis, protein synthesis that happens rebuilding musculature is collagen, collagen building. So that's one of the main first building blocks of muscle is the collagen fibers. So absolutely, absolutely.
Perfect.
So now our favorite, the darlings of the peptide world, BPC 157 and TB 500. So these two together are really creating structural integrity, angiogenesis, and inflammation modulation. And we've talked about it before, but this model really shows you what each one does. So BPC 157 is working on tendon and ligaments. It accelerates healing of soft tissue injuries and promotes fibroblast migration. It has anti-inflammatory properties. It's modulating the inflammatory properties, resolving chronic tissue irritation and the chronic inflammation. And it also protects the endothelium and supports gastric mucosal integrity. This is really important when we talk about BPC being really good for healing the gut. It's actually a gut-derived peptide, so it's actually one of the main places where it's actually made naturally in the body is in the gut, and it goes a long way to really help that endothelial layer and the mucosal integrity of the lining of the gut. So the TB500 works on angiogenic signaling, so it's stimulating the formation of new blood vessels to improve the tissue perfusion, and it's it's upregulating the vascular endothelial growth factor for repair signaling, so the VEGF modulation and endothelial repair. It's promoting the actin polymerization and cellular migration to wound sites. So the BPC 157, again, I always use the analogy of like it's like the firefighters that come into the building that's on fire. It sets out it puts out the fire, and it sort of like pickaxes out all the dead, all the burnt parts, like all of that inflammation, and modulates those inflammatory pathways to bring the inflammation down. And then it's protecting that endothelial layer. And the TB500 is sort of like the new architects and engineers that come back in, uh, signaling angiogenesis, the rebuilding of more and bigger, better blood vessels to improve, more blood going to an area means more regeneration, right?
Mhm.
So upregulating the VEGF for repair signaling and endothelial repair. So those two work really, really hand in hand, and great combination. Can be used together, can be used separately at different times, but they both build each other up. KPV. This is one that we've talked about very little, really.
Yeah.
Um, it's sort of like the redheaded stepchild that kind of comes in like number 4 in the group of BPC, TB, GHKCU, and the last one is KPV. I'm starting to realize how important this one is. So this one's really working on inflammation as well, but it's working in a different way, and it's very important because the NF kappa B and it's that inflammatory pathway is sort of the biggest, largest inflammatory pathway in the body, right? So the KPV is really important because it's inhibiting the NF kappa B light chain enhancer pathway that stops inflammation at the source. So it's really down regulating it by stopping it at the source, where BPC 157 is modulating it by pulling some of it out and cutting down on the inflammation. The KPV is really going right to the source of the NF kappa B modulation. So anti-inflammatory signaling, broad spectrum anti-inflammatory effects without immunosuppression. Now, we say without immunosuppression, but it is working on that NF-kappa B modulation and some other inflammatory cytokine pathways as well, which do deal with immunosuppression to some degree. So KPV is something that can't be really cycled every day forever, like BPC and TB can, or even GHKCU copper can be literally used every day for the rest of your life if you wanted without issue. The KPV used more than like maybe 7 to 10 days in a row in high amounts could start bringing more immunosuppression than one would really want. So this is one that I suggest people use like 3 times a week, 3 to 4 times a week. If you're going through something intense and you need that NF-kappa B modulation like intensely over like let's say a 7 to 10 day period, you could use it every day, but I wouldn't suggest it for long periods of time. Definitely, if it's used every day, should be cycled off like pretty quickly, small cycles. This is really key factor in inflammatory pathways that lead to gut and bowel conditions, gut healing. So, BPC 157 is known as a really good gut repair peptide. KPV is also amazing for that. In fact, almost maybe better than the BPC in many ways. So it also has immune calming. Um, uh, it has immune calming. What am I trying to say? Sorry, guys, I'm kind of tired tonight. It's been a long day.
Immune calming
Uh,
effects.
Immune calming effects. It brings homeostasis to overactive immune responses, which again, like I said, it can bring homeostasis and balance to overactive cytokine pathways and immune pathways. But again, not to be overused because it could underregulate, it could downregulate too much those immune pathways if not used carefully.
So you could
So
really clamp your own immune system down and cause some issues for yourself
absolutely.
or your
Which is
kangaroo,
which
really.
is my big qualm with people using the Clo stack. And a lot of people using that, every day, but thinking it's just like BPC-TB and you can just use it every day. It's just one of the factors why I don't think that's a good thing to put all in one vial and use daily. Because KPV is something really best served, 3 to 4 times a week with
Now,
breaks in
I'm going to
between.
ask about a nasal on that one, especially since you would be doing it, 2 or 3 times a week, and also not cycle it as much. That seems like it would be a perfect candidate for a nasal
Yep,
with
the nasal spray delivery of the KPV peptide works very, very well. Very, very well. I've actually even used it on my skin, believe it or not. I think I mentioned this a couple weeks ago, but I've been dealing with a little bit of folliculitis, like on my hands and my arms, just a
Mhm.
little bit, and it's pretty much cleared up almost. There's a couple little tiny red dots there, but it's almost cleared up completely now. It's getting much, much better. When I was going through it and it was pretty bad, um, I was actually spraying the KPV directly onto the skin, and kind of just patting it in and letting it dry up on the skin. The way that the nasal sprays are working with the Protixa Ion technology, there it works on the opening and that weave, that tight weave of the epithelial layers, like we've been talking about in the mucosal
Mhm.
membranes in the nasal cavity. It also
Mhm.
does the same thing on the epithelium on the skin, the epithelial layers of the skin. So it can have that same effect of opening those and allowing for more penetration.
Hmm. Now,
So
did you notice? I have a quick question. Did you notice when you sprayed it on topically, did you notice an immediate relief of that? Because I know that can be somewhat a little bit itchy at times.
uh I haven't really had much itch with the folliculitis that I've been dealing with.
Good.
It hasn't really been itchy per se, but I just noticed that the redness over the course of 2 days when I had been doing other things that didn't help, and then I did that, it seemed to like really spike up some healing like very quickly over the course of a couple days.
Hmm.
I would say it kicked it up quite a few notches, the healing
No, nice.
of the actual like little sores on the skin.
Oh, very nice.
Yeah. So let's talk about epitalon. So this is not one that we've really talked about, I
Mhm.
think, at all on this webinar in any of the episodes so far. So this is a pineal and telomere peptide. So it's a tetrapeptide, it's synthetic 4 amino acid peptide. It's based on the pineal extract epithalamin, right? So it brings telomere activation. So it's stimulating telomerase activity and promoting telomere elongation and chromosomal stability. So this is really important when we're talking about anti-aging
Yeah, longevity.
and longevity. As we age, the telomeres, they're those little long guys, right? And the length of the telomeres, they just start shortening and shortening and shortening. And in people who age quicker, it's always seen the telomere as you age, you know, quicker and quicker, the telomeres are shortening and shortening and shortening. So when you have telomerase activation and you promote the elongation of those um, at a chromosomal level, you're literally anti-aging. Like you're creating longevity at like the source.
Yeah.
So this also helps with circadian regulation. So it's working with the hypothalamus and hormonal signals resetting biological rhythms. So we talk about that, which brings us into circadian rhythm sleep. It works on melatonin modulation. So it's normalizing and sort of balancing out a natural endogenous melatonin production external of any melatonin that you take, right? So oftentimes people will take melatonin because they can't sleep and they'll take it night after night after night, and you kind of become dependent on it, and your body has a hard time creating the melatonin anymore because you've been taking it exogenously for so long. The same thing happens with testosterone with men. You know, you
Yes.
have low T, so you start taking testosterone, and the more testosterone you take, the harder it is for your body to start producing it again on its own when you go off of it because it's been getting it exogenously and hasn't needed to produce it.
Hmm.
So,
End up with some raisins.
yeah, exactly right. So,
Sorry.
circadian rhythm is really important to repair. So this goes back to our circular thing of, you know, ATP production, mitochondrial efficiency, NAD infusion, all of that focusing downstream on actin remodeling, on angiogenesis, on um, genetic remodeling of come on, what am I trying to say with the GHKCU?
Oh, like a
Collagen.
collagen?
With
Collagen
collagen.
remodeling.
Sorry, there we go. Collagen. I
Okay.
apologize, guys. I am off tonight. I'm like super tired tonight. Um, so getting that back on, and we talked about this a little bit with the DSIP last week, right? When we had our DSIP masterclass talking about
Hmm.
circadian rhythm and how one of the main things that DSIP does is it brings natural circadian rhythm back by inducing correct cortisol timing and rhythms and bringing those back where they should dip sort of in the early evening and dip down and then about 9:30 or 10 start slowly upticking back rather than staying high and then ticking up again. So, you know, you're thrashed and dead and ready to end your day by noon the next day in modern life, right? So,
Yeah.
um, this epitalon is awesome too. Don't ever make the mistake of taking it during the day. I did this once at work and I literally was like falling asleep at my desk. It was pretty intense and it wasn't fun. This brings definite sleepiness. Like it will absolutely bring sleepiness to your life. And it does that through melatonin modulation.
So epitalon is like the Sandman.
It is like the Sandman. Yeah.
I do have one question that came in from Heather, and it's about endolutin. Um, is that similar to the epitalon? And what are the differences if you happen to know?
I don't know.
Okay.
I can't answer that.
That's okay. I'm going
I'm
to
not familiar with endolutin. Let's put a pin in that one and bring that back next week with some answers.
exactly what I was going to do. Let me go grab my notebook.
Endolutin. Not familiar at all. You don't know what you don't know until you don't know it. So the next one we're going to talk about is thymulin. So this is a thymic peptide produced in the thymus gland. It requires zinc for biological activity. It works on T cell maturation, so it's driving the differentiation of T lymphocytes that are crucial for adaptive immunity. So thymulin is actually very well paired with the epitalon. And there was actually a researcher, Covinson, he's kind of known as the father of peptides. He actually developed many of the nootropics in the late 70s, early 80s as well that we know, like the racetam group and some others, and did a lot of study with those. But I was reading a study not too long ago where he was actually healing people from blindness with a thymulin epitalon blend. And it actually wasn't epitalon, it was epithalamin, which is like epitalon is sort of like a fragment of the epithalamin. Um, it's like the most useful fragment of it. But he was actually bringing people back from like full blindness with these two peptides, which is insane, right? So this is driving differentiation of lymphocytes crucial for adaptive immunity. It's bringing immune balance. It's helping um, suppressor T cells. So it's modulating the ratio of helper to suppressor T cells, preventing autoimmunity. So this is also a really good one for people who are dealing with autoimmune illness, because that oftentimes is because you have too many of one type of T cell, right? And so your body starts acting upon itself, thinking certain things are exogenous when they're actually endogenous. In my case, I deal with rheumatoid arthritis, which is an autoimmune issue. And it's basically my body is trying to activate against my own joint fluid, right? So that's why rheumatoid arthritis, it attacks your joint fluid and tries to break that down because it thinks it's an outside, it thinks it's like an outside source, and that's not good. So that happens when you have the wrong ratio of suppressor T cells. So um, this also works on immunosenescence. So it's reversing age-related decline in immune function. So as we age, oftentimes our immune system senesces, right? It gets old as well. So it's kind of reversing the age of our immune system from like a very cellular point of view. So, and it's actually working um with an interaction on like you could call it, like it says here, the neuroimmune interaction. So it's working on a neuroendocrine axis also with the thymus, and it's linking immune function with the nervous system. So we talk about pathways all the time when we're talking about peptides, like what signaling pathway is that working on? And we also talk about crossing signaling pathways and nodes of signaling pathways. So when we're talking about using different peptides, we want to make sure that we're not using the exact same pathway at the same time and creating signal noise, and that we're also not getting too much oxidative crosstalk between pathways. And we want to make sure that the ones that we're using in conjunction at the same time with each other are actually copacetic and linking at those pathway nodes, right? So thymulin is actually working on, on an axis of two pathways. It's working on the neuroendocrine and on the CNS, the central nervous system, right? So thymulin is actually a pretty important immune modulating peptide. And we'll probably maybe even do a master class on epitalin and thymulin in the future, because I think these two are very, very important.
Well, the fact that it could help restore vision, I'm all for it Because as you
Yeah,
see, I'm wearing these spectacles. That was not always part of my repertoire. So
right, right.
move that back, or my giraffe, we can move that back, that'd be amazing.
Absolutely. So when we talk about regeneration, it's systemic, and peptide therapy works by amplifying natural crosstalk between the five critical biological systems. Like I just said, it works between different pathways on different biological systems in the body. And again, when we talk about peptides, we're really talking about signaling, and we're talking about biological return and biological repair to proper signaling as it should be in the body naturally, right? We're really talking about homeostasis of things. So this is the regenerative model right here. This ties it all together. So we've got five main places that we're working on here: energy, which is the mitochondrial ATP and NAD plus availability; signaling, so peptides are amplifying the repair messages. The repair is actually cellular reconstruction and synthesis. Remodeling is the tissue organization and integration. So we're talking about, cellular repair, we're talking about NAD plus, the mitochondrial repair, moving right into remodeling tissue organization and integration. We're talking about the BPC, the TB, the GHKCU, and then resilience, adaptation to the future stressors. We start talking about things that are anti-aging and bring resilience, like the epitalon and the thymulin and things like that. So the goal isn't to just repair the damage, but to create a system that was stronger than before, right? And it all starts with energy and ends with resilience. So the key takeaways of tonight's class is regeneration begins in the mitochondria. Inflammation must resolve before the repair, which is why, the BPC happens with or before the TB 500, and the metabolism dictates the recovery. So if the mitochondria is not bringing the proper insulin sensitivity and glucose uptake, then metabolism is going to dictate like a downturn in recovery. So if that's all acting how it should, recovery should happen at a quicker rate. And the idea that peptides are acting only as signaling amplifiers. We've talked about this time and time again, that peptides are not drugs. They're not working on binding affinities and causing things to exogenously happen in the body. All they are is signals that already exist in the body that we're turning on. You're just sending an email to a receptor site on the face of a cell somewhere in your body, in a particular system, in a pathway, that's saying, hey, open that pathway or close that pathway or start signaling like you haven't been doing your job, or pipe down, you've been doing your job too well,
Wake
whatever it
up or
might
shut
be.
up. One of the two.
Wake up or shut up. Yeah, exactly. So the key takeaway with this that I wanted to bring together with tonight's presentation was that no single peptide is the answer. And I kind of mentioned this in the beginning.
Absolutely.
They're all very targeted in their own ways, but they are realistically all kind of like a multi-pronged approach to getting all systems working collectively correctly in the body. So, successful regeneration requires a systems biology approach moving beyond symptom management to cellular restoration. So, instead of masking symptoms with drugs, we're actually working at an intracellular level on signaling in these pathways in the body to basically return to homeostasis and return to natural rhythms, circadian rhythms, etc. in the body. And that's the presentation for tonight.
That was great. Now, I think we got some questions throughout. I just wanted to see if anybody had any additional questions that they may want to get addressed or that we could talk about. I do have a note about that endolutin, so we will do some research on that and bring back good stuff about that next week. Um, And also with the peptides, it just reminds me of that, we can be on a downward spiral. And so many of these peptides, when you use them in conjunction in the right way, it becomes an upward spiral
Yeah.
where you are slowly and steadily moving up, like an escalator or a rampart going around in an old stadium. Um, and it's just like an escalator moving you up to a better and better health. Um, or it just improving some maladies or things that you may deal with. For me, leaky gut is probably been an issue, and it's definitely helped in my experiments. So I
Yeah,
wanted to thank you, Chris.
you might want to look at some SS31 as that really does help
Yeah,
improve the electron transport and which is the breakdown when that's inefficient and working improperly is what's causing that leaky gut. So
yeah. So
yeah.
um, it, I absolutely appreciate spending these Tuesdays with you guys and learning more myself. Try to add what I can, but we all learn from each other. And also, we just got Alba. Is there a way that we can feed the mitochondria with food? And we actually missed nutrition on this episode, which we normally hit um, pretty well. But one is the proteins, especially when you're doing any peptides. You need to make sure that you have a good quality protein source. Um, and if you're on any of the agonists, you absolutely need to make sure that whatever you're eating is nutritionally dense. Uh,
Yep.
with
Yeah,
that,
that's a very important thing that I try to hit home always when working with somebody on a GLP. And for the record, I don't work with anybody on GLP-1 or 2. I don't suggest them. I think they're both trash. Sorry if you're taking them and have had great things with them, but retatrutide is just far better in every way, shape, and form. But when you were on it, it is very important to make sure that, like Tony just said, make sure that because you are eating less, make sure that your nutrition is dense, that you're getting the proper calories and you're eating the proper things to get what you need. Make sure you're getting enough protein for protein synthesis so that you experience any muscle loss along with that. Um, very important. Very, very important.
and foods for mitochondria. That's a good one. That I'm not. I mean, other than obviously your omega 3s, your vitamin C, your Ds, your D3, K2s, uh, all of those. Obviously, you want to have, especially the omega 3s for the cell walls, as your body is
Yeah,
sardine. Yes, absolutely.
they're foods that provide good glucose for glycolysis.
Okay.
Sweet potatoes, oats,
Oh yeah.
quinoa, brown rice, most fruits, healthy fats that provide, fatty acids for beta oxidation, like
Mhm.
avocado, olive oil, nuts, seeds, fatty fish, ketone
Sardine.
producing foods like coconut oil, MCT oil, grass-fed butter.
Mm.
Um, Ketogenic diets in certain contexts can be very feeding to mitochondria. Vitamin B rich foods are great for mitochondria, eggs, organ meats, whole grains, beans, leafy greens, um,
Spinach is a great one.
blueberries,
Mm.
polyphenol rich foods, blueberries, pomegranate, dark chocolate. Let's see, coffee would be one of those. Green tea,
That's pretty
um,
much it.
CoQ10 precursors as well. Broccoli, spinach, a lot of different meats, sardines, mackerel, beef, chicken. I'm grossing myself out here, Mr. Vegan guy, talking about all these meats for
That's
mitochondria.
just an option. It's an option.
Yeah. So chia seeds, flax seeds for the
Mhm.
vegans, salmon and sardines for the non-vegans. Those can all improve membrane fluidity and mitochondrial signaling. Pumpkin seeds are great, dark leafy greens. Um, those almonds, those all have like rich in mitochondrial minerals. Yeah, iron, magnesium, and copper.
Yeah, I always like to look at it because we use the house building um, analogy with the Motzi, uh, and very much you wouldn't start building a house without all the supplies you needed to build it.
Yeah.
So we're doing these peptides. You're putting them into your body. You're getting yourself supercharged to build like crazy, and you got an empty warehouse.
Heather asks, sardines?
Yes, sardines.
Sardines are like little mini fish. They're like little fish that come in like little metal packets if you've never had sardines before. Sometimes people put them on pizza.
Some people do. My dad, yes, he used to like sardines. Um, he
I think they're really salty, right? They're like extremely salty. They're like usually in like a brine kind
They
of.
can be, but you can also get impacted just in water.
Yeah.
Yeah.
Okay.
I mean, you eat them bones and all, and they are. I mean, the bones are pretty soft. You don't even really realize that you're eating the bones. But yeah,
Yeah.
you just eat the whole fish pretty much.
So Heather also asked thoughts on liquid ketones. Honestly, I've never really used any liquid ketones. I'm
Yeah.
not really familiar that much with ketones and taking ketones exogenously, sorry.
I've just used MCT oil. The MCT8 basically does a great job of kicking up your body's own natural ketone production. It pretty much goes right to the liver when you ingest it, and your liver turns that pretty much right into ketones. I'd prefer rather than taking a liquid ketone, do something like that. I think, as we've talked with some of the peptides, you don't want to shut down your own body or regress your body's own ability to produce some of these compounds. Um, and I don't know
Agree.
enough about liquid ketones, um, if that will happen, but I do know that MCT8, and you can find several different brands. Bulletproof is one that I know is primarily 100% MCT8. So, but you can find other brands that one's just a popular one, but there are other ones that you can find that have that. And you can find most of the MCT oils that you will find will be a blend unless they specifically say that they're MCT8. So you get an MCT10 and MCT12 in them as well, which aren't bad. They just don't stoke up the fires for ketones. Do you know, for a quick nerd fact, the ketogenic diet was originally used in the treatment of epilepsy?
Oh, really?
Yeah, it was discovered by a Russian doctor. He was a physician that treated epilepsy, and one of his patients had, oh, this will not thrill you at all, but was eating bacon uh, just like crazy, and they noticed during that period of time that their symptoms had gone down. They hadn't. So he started feeding them a very fat, rich, cut out all the carbs pretty much out of their diet and gave them a very fat, rich diet, and reduced their epileptic seizure episodes dramatically. So
Wow.
just a
Interesting.
little I don't know, useless fact or a little bit of history, I guess.
Useful to the conversation for sure.
Absolutely. Absolutely. So um
Cool.
I hope
All
everybody has
right.
a wonderful
Well,
evening.
that
And
was a fun talk tonight. I hope everybody enjoyed it, and we will see you next week.
everybody have a good one. And oh, before I go, I was thinking about doing melanotan too next week.
Yeah,
Which,
that'd be a good idea. Maybe we'll do a little masterclass on that like we did on the DSIP.
yeah. Well, I was going to follow that up, but I'd already had this regenerative one already there. So we got a break, and then we'll do the melanotan too. So I'll get those links out to everybody. If you're on this call, you will get an email. You'll get two. You'll get one this week, and then you'll get one on the day of the webinar. Just to remind you that we're going to be here. You guys have a wonderful evening, and I will see you all next week. Have a fantastic rest of your week. Make it a prosperous and enjoyous one.
Peace
Ciao.
out.
Peace.